Hello everybody, in Module 3 I discussed models of agency problems. Module 3 has 6 lessons. Today we're focused on lesson 3. The role information plays in moral hazard settings. In the previous lessons, we know that in moral hazard settings, the agent's effort levels are not observable. Therefore, the contract has to include observable outcomes to induce the agent proper incentives to work. Those outcomes can also be interpreted as performance measures. A natural question is, what kind of outcomes or performance measures should be included in the contracts? Should the contract include all possible observable outcomes or performance measures, a proper subset of it? And if a proper subset, what kind of proper subset? Those questions are answered in Holmstrom 1979 Bell Journal of Economics paper. We're just going to discuss the big picture intuition. We're going to skip the technical details. The simplest question in this setting is, suppose we got two performance measures, X and Y. When would contracting on the second one, let's say Y, provide strictly positive incremental value relative to contracting on X alone? Without moral hazard, in a decision-making context, Y has strictly positive incremental value if Y is not dominated by X in the Blackwell sense. We're not going to provide a precise definition of the Blackwell sense, but intuitively, if X dominates Y in the Blackwell sense, that means X contains all the information that Y has and more. In a setting with moral hazard, Holmstrom shows that Y has no incremental value if and only if X is a sufficient statistic of X and Y given the effort level. The sufficient statistic condition, while weaker than Blackwell dominance, is still pretty strong, which means that so long as X is not a sufficient statistic for X and Y given A, the agent's effort, Y should always be included in a compensation contract. It also means that because sufficient statistic is a very strong condition, the compensation contract should in principle include a lot of observable outcomes based on Holmstrom's 1979. What's the definition of a sufficient statistic? The first bullet point provides the technical definition of X being a sufficient statistic for X and Y given A. Intuitively, what it means is Y has no incremental information relative to X inferring agent's action. One example is Y equals X plus some noise. In this case, including Y provides no additional benefits in inferring agent's efforts. X itself is enough. If the contract varies based on Y, it can make the problem worse because Y is a noisy version of X. So including Y is going to pose more risk on the agent without improving incentives. What is the intuition for if X is not a sufficient statistic for X and Y, you should include Y? Well, because even if the agent is risk averse, locally for small variations, agent is risk neutral. So for small enough variation, if Y is sufficiently informative, if Y is not dominated by X in the sense that X is a sufficient statistic for X and Y, then including Y is going to help improve the effort incentive in the margin because locally, the agent is risk neutral. Technically, the argument is quite involved. So Holmstrom's original paper provides enough details for you to take a look. Holmstrom 1979 focuses on the case when the outcomes are publicly observed. What if some information, some outcomes are privately observed by the agent? Well, there are two streams of literature, depending on whether the private information is observed before the agent exerts efforts, and the literature is called pre-decision private information, or the private information is observed after the agent exerts effort, and the literature is called post-decision private information. Due to the information being private, there are two effects. First, the agents can use this private information to the agent's own advantage in choosing efforts. That's when the information is observed before the agent exerts effort. So for example, suppose the agent knows that the general environment is good. So even if the agent is not working, the outcome is going to be good. Then the agent has less incentive to work. The second effect is even when the agent observes the information after exerting effort, because the information is private, the agent has no incentive to report such information truthfully to the principal. The pre-decision information literature has both of those effects. The post-decision private information literature only has the second effect. And the cost of agent using those private information to their own advantage, or the cost of inducing the agent to report such private information truthfully, can be so large, it would be more efficient to exclude all the post-decision information in the contract, or discourage the agent to acquire any pre-decision private information. For subsequent discussions, we focus on post-decision case to preserve continuity with Holmstrom 79. The discussion is going to be based on Dye 1983 JAR paper. And we're just going to discuss a binary version. So here's the setup. The agent exerts effort that can be either AH or AL. There is a publicly observed outcome Y that is either YH or YL that is informative of the agent's effort. After exerting the efforts, the agent also observes a private signal X that can be XL or XH. And we assume that X is a sufficient statistic of X and Y with respect to A. What it means is, if X is publicly observed, then based on Holmstrom 1979, the optimal contract should only include X, should not include Y. What Dye shows is that even when X can only be privately observed by the agents, because X is so informative, it is still beneficial to include X in a contract, of course, because X is agent's private information. The contract will include a report of X in the contract. Of course, the contract also has to include Y. If the contract is only based on X, then there is no way for the agents to credibly report X. The principal is risk neutral, the agent is risk averse, as in typical agency models. The agent has the utility function that is based on the payments, that is a function of the reports of the private signal X and the public observed outcome Y, minus the agent's cost function. Again, we normalize the cost of exerting low effort to be 0, and the cost of exerting high effort is V. The principal chooses the optimal contract to minimize the expected payment to the agents, which is equivalent to maximizing the expected payoff to the principal, subject to 4 constraints. In addition to the usual individual rationality, or IR constraint, and incentive compatibility, or IC constraint, in the basic moral hazard setting, there are 2 more constraints. Because the agent observes X privately, the contract needs to make it incentive compatible for the agents to communicate truthfully about X. When the agent observing XH, it is optimal to say that it's XH rather than XL, and vice versa when the agent observes XL. That's why you see the 2 truth-telling constraints. One when agent observes XH, and one when agent observes XL. We're going to talk more about this when we talk about adverse selection in lesson 5. And so how do we solve this optimal contracting problem? As usual, the key is to figure out which constraints bind, or which constraints hold with equality. The IR and IC, they're going to bind for the same intuition as in the basic moral hazard setting. Your IR has to bind because otherwise the principal is going to leave money on the table. You can reduce payment to the agent and still satisfying the constraints. The IC binds because you have the moral hazard problem. If IC does not bind, then the moral hazard problem is not going to exist. We can show that the truth-telling when observing XH is not binding, but the truth-telling constraint observing XL binds. Here's the rough intuition. Because XH is more likely when the agent exerts high efforts. So you're concerned about the agent not exerting high efforts, but choose to tell you the agent observes XH in order to trick you into believing that agent exerts high efforts. So that's why you want to make sure that if the agent observes XL, the agent has incentive to say it's XL, not XH. You're not concerned about if the agent observes XH, the agent is going to lie to say it's XL. And so we now have three constraints binding. We have IR binding, we have IC binding, we have truth-telling XL binding. And also, truth-telling XH non-binding implies that when the agent reports X is XL, you give the agent a fixed wage, which means that it does not depend on the realization of Y. And why is that? Because if there's any spread when the agent is reporting XL and the spread varies with Y, you can always reduce the spread. Because the truth-telling XH is not binding, the reduction of the spread is going to improve risk sharing. So we have three binding constraints as described above, and we have three unknowns. The payments when the agent reports XL, and the payments when the agent reports XH, and the outcome is either YH or YL. You solve them, and you get the solution. The solution has the following properties. The expected payment to the agents when the agent reports XH, and when the outcome is YH, and when the outcome is YL, they are identical to the optimal contract when you only contract on Y. Essentially, when the agent reports X equals XH, you're kind of ignoring the agent's report. When the agent reports XL, the payment to the agent is identical to the optimal contract if X is publicly observed and contracted. So here's the intuition. Because X is more informative than Y, X is a sufficient statistic of X and Y with respect to A. So if X is public, the contract should refer only to X because X improves risk sharing much more than Y. However, because X is private, we only use X when XL is reported. Because when XL is reported, I'm not concerned that you're lying. I know that you exert high effort, you're just unlucky to observe X being XL. So I'm going to ensure you, I'm going to use X. But if XH is reported, then I cannot be sure that you're telling the truth. Even though equilibrium, you're telling the truth. So the contract does not refer to X at all, and then just the contract on Y. And where does the efficiency improvements come from? The efficiency of or the improvements, it comes from the agents who observes XL. In this case, the agent is insured. There is no spread in the agent's contract based on variation in Y. Agents who observe XH, they would have no incentive to report XL, to enjoy that insurance, because they think they're more likely to observe YH. So because they're going to get paid more when they report XH and the observed outcome is YH, so their expected payout is going to be higher, it's going to outweigh the risk imposed on them. So what do those models have to do with accounting? Now think about X as voluntary disclosure and Y as mandatory disclosure. So this is proposed in Gigler and Hammer 1998 JAR paper. They interpret the case of X being a sufficient statistic of X and Y as voluntary disclosure contains all the important information. Mandatory disclosure only plays a confirmatory role. The only reason for mandatory disclosure to exist is because Y is verifiable. You need Y to verify, to confirm what the agent reports about X, the voluntary disclosure. So they used a lack of market reactions to mandatory disclosure to justify this interpretation. The voluntary disclosure earnings forecasts, they're more informed and they're more timely than earnings announcements. Earnings announcements, they only serve to confirm that the information conveyed in the forecast are accurate, makes sense. And this confirmatory role is tested and confirmed by the Bo et al. 2012 JAE paper. They test the following hypothesis. they're saying that if a firm commits to higher audit fees, that means the firm is committing to higher quality mandatory disclosure. So the confirmatory role is stronger, which means that the firm is more likely to issue more precise voluntary disclosures. And so they find that higher audit fees are associated with more informative voluntary disclosure management forecasts. So to conclude, when information signals are publicly observable, they should be included in contracts, so long as they have incremental information value. And there is a technical definition for what it means to be incrementally informative. When information is privately observable, they should be included in contracts so long as they're sufficiently informative. One example of being sufficiently informative is the private information is a sufficient statistic for some publicly observed information. In this case, you can interpret the publicly observed information as confirming the private signal. In the accounting context, a good example is the private information being voluntary disclosure, earnings forecast, and the publicly verifiable information as mandatory disclosure. This is the end of this lesson. If you want to test your understanding of this lesson, a review quiz can be found at the link on the slides. Thank you very much.